Welcome to the isolation of eugenol from closed lab. This is a natural product extraction lab and it's actually one of the fun labs. If you know what cloves are, cloves have a very distinct aroma, and in lots of cooking, especially Asian dishes, we see the use of cloves. One particular ingredient in cloves known as eugenol is responsible for giving cloves their distinct taste and smell. In this lab we can smell eugenol and can quickly relate it to cloves without having to think about where that smell originates from. They have a very distinct aroma. Now, how exactly are we going to extract eugenol or isolate eugenol from cloves? We'll pulverize about 5 grams of cloves, and I have done that already. This is about 5 grams of cloves in here. We will add this to a 250 milliliter round bottom flask and add about 150 milliliters of water, set up our distillation assembly, and we will start the distillation. What kind of distillation do you think this would be? In one of the previous demos I mentioned that a lot of natural products are extracted through steam distillation, and this is going to be the case here as well. This will be steam distillation. We will be extracting our compound of interest from this matrix of the clove pulverized powder, and together with that we will have water. When will we stop our distillation? We will stop our distillation when we do not get any more water insoluble organic liquid, as we have done in previous labs. However, we will not just collect eugenol, we will collect one more compound, an extremely similar compound known as acetyl eugenol. Both are very similar except for one difference, the presence of a group known as acetyl group. Now, once we have that, what will we do? We have a mixture of acetyl eugenol and water. We will move it into a separatory funnel and separate the two layers, keeping the organic layer and discarding the aqueous layer, thereby just having acetyl eugenol and eugenol. But now both of those are organic neutral compounds. How will we separate them? Here we are going to utilize the fact that eugenol has an OH group on it that is fairly acidic. A very strong acid, a very strong base can actually deprotonate it, making it a negatively charged ion. Together with the positively charged cation from the base gives you the salt of eugenol, such as the sodium salt or the potassium salt of eugenol. That's what's going to make it ionic, and as an ionic compound, as an ionic salt, it will not dissolve in the organic phase. It will move into the aqueous phase. So we are going to have our mixture of eugenol and acetyl eugenol as an organic phase in our separatory funnel. From there we will add some strong base, potassium hydroxide to be exact, and then it's going to deprotonate and convert eugenol into the salt of eugenol, and it's going to move in the aqueous phase. And then acetyl eugenol will remain in the organic phase, and our salt of eugenol will be in the aqueous phase. Now we are going to separate the two layers, and we are going to discard one layer. Which layer will we discard? We will discard the organic layer then. The organic layer contains acetyl eugenol, which we don't need, which we are not trying to extract. We will keep the salt of eugenol in the aqueous layer, and then we will add hydrochloric acid to it. It's going to reprotonate our salt of eugenol, which was deprotonated by potassium hydroxide. And once it's protonated again, it's converted into eugenol, and it will not dissolve in the aqueous phase. It will then want to move into the organic phase. The organic phase we'll utilize is going to be dichloromethane. And now that it has moved in the organic phase, we will discard the aqueous phase, keeping the organic phase. And from that we will do our final distillation. And this time it's not the distillate that we are collecting. The distillate will be dichloromethane, which has a very low boiling point. But once all the dichloromethane has distilled over, what will be left over in our distillation flask will be a pale yellow liquid which is eugenol. Eugenol has a very high boiling point and it does not distill easily. In fact, it's likely to decompose because of its high boiling point. And that's how we will isolate eugenol.